Good morning everyone. In today's video lecture we are going to discuss about subject name is basic civil engineering and mechanics. In today's video lecture we are going to discuss about unit 4, that is forces and equilibrium. Myself Professor Sunil Kumar Thakur, assistant professor in civil engineering department. Now today topics to be discussed in this video lectures are fundamentals of engineering mechanics, system of forces, characteristic of a force, some important definitions, methods for the resultant force, moment of a force, Varignon's principle or law of moments, and last, that is Lami's theorem. Now, one by one we are going to discuss about these topics in details. Also in some topics numerical portion also available here. Now first topic is, that is fundamentals of engineering mechanics. When we talk about engineering mechanics, the subject of engineering mechanics is that branch of applied science which deals with the laws and principles of mechanics along with their applications to engineering problems. Now, the subject of engineering mechanics may be divided into following two main groups, that is statics and dynamics. Now, we talk about statics. It is that branch of engineering mechanics which deals with the forces and their effects while acting upon the body at rest. In this case, the object or body may be at rest before and after the application of forces. Now, what about dynamics? It is that branch of engineering mechanics which deals with the forces and their effect produced on that body while acting upon the bodies in motion. Means in this case, when we are going to apply forces and the effect produced of that forces on that body, the body may be in motion. Now we talk about system of forces. This is another important topics of this unit. When two or more forces act on a body, they are called to form a system of forces. Following system of forces are important from the subject point of view. Now one by one we are going to discuss about these forces. First of all, we are going to discuss about coplanar forces. Coplanar forces whose line of action lie on the same plane are known as coplanar forces. For example, all 2D's diagram comes under this category. Now, collinear forces, the forces whose line of action lie on the same line are known as collinear forces. In this case, whatever the direction of force, it may be rightward or leftward, but the direction of or line of action should be same. Now, concurrent forces, the forces which meet at one point are known as concurrent forces. All those forces which passes through a single point are known as concurrent forces. Coplanar concurrent forces, the forces which meet at one point and their line of action also lie on the same plane, are known as coplanar concurrent forces. What about coplanar non-concurrent forces? The forces which do not meet at one point but their line of action lie on the same plane are known as non-concurrent forces. Now, non-coplanar concurrent forces. The forces which meet at one point but their line of action do not lie on the same plane are known as non-coplanar concurrent forces. Non-coplanar means here 3D diagrams comes under this category. Now, non-coplanar non-concurrent forces, the forces which do not meet at one point and the line of action do not lie on the same plane are called non-coplanar non-concurrent forces. Now in next slide. Now we are going to discuss about characteristic of a force. When we talk about a force, what is the characteristics of that force? Now, in order to determine the effect of a force acting on a body, we must know the following characteristics of a force. First one is magnitude of the force. Magnitude means how much Newton load or force may be applied on the body. It may be 100 Newton, 50 Newton, 20 kilonewton, 5 kilonewton, etc. These are the units of force. Either it is in Newton or kilonewton. Now in second point, the direction of the line along which the force act means magnitude as well as direction play an important role. Direction should be along OX, along OY, at 30 degree north of east, etc. It is also known as line of action of the force. Now, nature of the force. Nature of the force, it may be push or it may be pull. What is the nature of the force? This is denoted by placing an arrow head on the line of action of the force. Arrow will play an important role. Arrow may guide us what is the direction of that force or what is the nature of that force. Either it is right hand side or it is on left hand side. It may be upward direction or it may be downward direction. From arrow we can consider as the nature of the force. Now the point at which the force act on the body, it is another important point when we are going to apply number of forces on a particular body. So first of all we have decide or we have to fix at which point all these forces acted on that body. Now in next slide we are going to discuss about the effect of a force. When we are going to apply the force on a particular object or on a particular body, and what is the effects of that force on that body. Now one by one we are going to discuss about that effects. A force may produce the following effects in a body on which it acts. First of all, it may change the motion of a body. When we are going to apply the force on a particular body, it may change their motion. If body in a running position, it may change, it may be stopped, and a body in a stop condition, after applying force, it may be change its motion. That is, if a body is at rest, the force may set it in motion, and if the body is already in motion, the force may accelerate it. Now in second case, it may retard the motion of a body. In third case, it may retard the forces already acting on a body, thus bringing it to rest or in equilibrium condition. In fourth case, it may give rise to the internal stresses in the body also. When we are going to apply number of forces on a particular object or body, due to that forces, there are internal stresses generated in that body on which it acts. Now in next slide we are going to discuss about some important definitions related to engineering mechanics. Principle of transmissibility. It states if a force acts at any point on a rigid body, it may also be considered to act at any other point on its line of action, provided this point is rigidly connected with the body. It means when we are going to apply the force on a body at some point, and we are going to continue that line of action of that force on same body, it may be effect equally at all the points comes under the lines of action. Now what about free body diagram? A free body diagram is a graphical illustrations used to visualize the applied forces, moments and resulting reactions on a body in a given condition. They depict a body or connected bodies with all the applied forces and moments and reactions which act on the body. The body may consist of multiple internal members such as a truss or be a compact body such as a beam. A series of free bodies and other diagrams may be necessary to solve complex problems. In other definition, in other language, we are going to explain free body diagram. Means we have to remove supports and applied reactive forces on a particular truss structure or a particular beam. That diagram is known as free body diagram. Now resolution of a force. In resolution of a force, it is a process of splitting up the given forces into a number of components without changing its effect on the body is called resolution of a forces. Generally, resolution along two mutually perpendicular direction must be. We have three equilibrium condition. In that three equilibrium condition, one have summation of h is equal to 0 means add all the horizontal forces, and second one is summation of v is equal to 0 means add all the vertical forces. Now what about inclined forces? In that case we need a resolution of a forces. In that case we are going to resolve that particular inclined force into two mutually perpendicular direction forces, that is horizontal force or vertical force. Now composition of a force. The process of finding out the resultant force of a number of given forces is called composition of a force or compounding of a force. Means, for example, if we are going to apply the number of force on an object and we are going to calculate a particular force of that combined forces, that is called composition of forces. Now what about resultant force? If a number of forces, that is P, Q, R, etc., are acting simultaneously on a particle, then it is possible to find out a single force which could replace them, that is, which would produce the same effect as produced by all the given forces. This single force is called resultant force, and the given force are called component force, and resultant force, it may be denoted as capital R. Now we have some methods for the calculation of resultant force. One by one we are going to discuss about these methods. Though there are many methods for finding out the resultant force of a number of given forces or given force system, yet the following are the important from the subject point of view. We have two methods, that is analytical methods and method of resolution. In analytical method, for resultant force calculation, the resultant force of a given system of force may be found analytically by the following methods, that is law of parallelogram or parallelogram law of forces, and second one is method of resolution. Now one by one we are going to discuss about these two methods for calculating the resultant force with the help of analytical method. Now what about parallelogram law of forces? It states, if two forces acting simultaneously on a particle be represented in magnitude and direction by the two adjacent sides of a parallelogram, their resultant may be represented in magnitude and direction by the diagonal of the parallelogram which passes through the point of intersection. Mathematically, resultant force, that is R, is equal to under root of F1 square plus F2 square plus 2 F1 into F2 cos theta. With the help of that formula, we are going to calculate resultant force, means magnitude of resultant force. And we have tan alpha is equal to F2 sin theta divided by F1 plus F2 cos theta. Through this formula, we are going to calculate inclination of that resultant force, where F1 and F2 forces whose resultant is required to be find out, and these are the adjacent sides of the parallelogram, that is F1 and F2. Now theta, what about theta? This is the angle between the forces. What is angle between F1 and F2? It is represented as theta. Now alpha is equal to angle which the resultant force makes with one of the forces, say F1, from horizontal direction, from horizontal axis. Now in next slide we have an example also for calculating the resultant force. In this example, we have two forces of 100 Newton and 150 Newton are acting simultaneously at a point. Means both the forces are acting at a point, means it comes under the category of concurrent forces. Means it comes under concurrent forces, coplanar concurrent forces. What is the resultant of these two forces? If the angle between them is 45 degree, means angle between force 100 Newton and 150 Newton, that is 45 degree, that is theta. Now we are going to solve this problem and calculate the value of resultant force. We have given first force, that is F1 is equal to 100 Newton. Second force, that is F2 is equal to 150 Newton. And angle between them F1 and F2, that is theta, is equal to 45 degree. We know that we have a resultant force, that is R is equal to under root of F1 ka square plus F2 ka square plus 2 F1 F2 cos theta. Now putting these given values in that formula, that is 100 square plus 150 square plus 2 into 100 into 150 cos 45. After calculation, we have a value that is 232 Newton. That is our resultant force. Now we are going to discuss about method of resolution. In method of resolution, first of all, we have resolved all the forces horizontally or vertically. If horizontal force is already available there, no issue. Vertical force is available there, no issue. But if we have inclined forces, for inclined forces we are going to resolve these inclined forces in two mutually perpendicular direction, that is horizontal direction and vertical direction. After that, after resolution, resolve all the forces horizontally and find the algebraic sum of all the horizontal component, that is summation of H is equal to. Now after that, resolve all the forces vertically and find the algebraic sum of all the vertical component, that is summation of V is equal. Now For resultant, we have a formula. The resultant R of the given forces will given by the equation, that is R is equal to under root of summation of H ka whole square plus summation of E ka whole square. Putting these two values in this formula, and with the help of that values we are going to calculate R, means that is resultant force. Resultant force. Now the resultant force will be inclined at an angle theta with the horizontal, such that the resultant force will be inclined at an angle theta with the horizontal such that tan theta is equal to summation of V divided by summation of H. And that inclination is always measured either from positive x-axis or from negative x-axis. After that, finding R and theta, we are going to calculate the actual inclination of that resultant force from first quadrant, from x-axis, positive x-axis. So we have four cases. In that cases, when we talk about first quadrant, in first quadrant alpha is equal to theta, means we have theta, that theta is directly equal to alpha. In second quadrant, for second quadrant we have alpha is equal to 180 degree minus theta. For third quadrant we have formula, that is alpha is equal to 180 degree plus theta, and for fourth quadrant that is 360 degree minus theta. So in that way we are going to calculate R as well as inclination of that resultant force from positive x-axis. We have a numerical also for calculating the value of resultant force. So in this example we have a triangle, that is ABC, has its sides AB is equal to 40 mm along positive x-axis and side BC is equal to 30 mm along positive y-axis. This is our positive x-axis, this is our positive y-axis. In positive axis we have given that is 40 mm, and in positive y-axis we have a value, that is BC is equal to 30 mm. Three forces of 40 Newton, 50 Newton and 30 Newton act along the sides AB, BC and CA respectively, as shown in figure. Determine magnitude of the resultant of such a system of forces. Now we are going to calculate the value of resultant force for such numericals. First of all, the system of given forces is as shown in figure. We have a figure. This is our figure for calculating the value of resultant force. From the geometry of the figure, we find the triangle ABC is a right angle triangle in which the sides AC, this is AC sides, means hypotenuse of that right angle triangle. By applying by property of right angle triangle, that is hypotenuse k square is equal to perpendicular k square plus base square. We have perpendicular value, we have base value. After putting that value, we are going to calculate value of AC. Pythagoras theorem. With the help of Pythagoras theorem, we are going to calculate this value, that is AC is equal to 50 mm. Now, in this right angle triangle, we are going to apply sin theta. Sin theta is equal to, generally, we have perpendicular upon hypotenuse. So 30 is perpendicular side and 50, this is hypotenuse. Now we get sin theta is equal to 0.6. Now cos theta is equal to base upon hypotenuse. We have base, that is AB is equal to 40 mm and we have hypotenuse value, that is AC is equal to 50. After putting these values in this formula, we got 0.8. Now resolving all the forces horizontally, that is along AB, we have two forces in horizontal direction. First one is 40 Newton force and this 30 Newton force is inclined force. First of all, we are going to resolve this 30 Newton force in two mutually perpendicular direction, that is along x-axis and along y-axis. This comes in positive x-axis, we have f cos theta, that is 30 cos theta, cos theta. We have cos theta is equal to 0.8. We have 30, we have put 30 cos theta. First, 40 Newton is having a right hand side, that's why we are going to take its positive, and that is 30 cos theta, that is in left hand side in number line. On left hand side forces we are going to consider as negative force, that is minus 30 cos theta. After putting value of cos theta in this equation, we have summation of H is equal to 60 Newton. After that, Resolve all the forces vertically along BC. Along BC, we have two forces. First one is 50 Newton and second one is 30 cos theta. 30 cos theta comes from this inclined force when we are going to resolve this inclined force into two mutually perpendicular direction. First one is cos component and second one is sine component. In this diagram, in this equation, summation of V is equal to 50. 50 we take positive because it comes on positive axis as the direction of force is upward. Upward direction forces we are going to take positive sign and downward forces we are going to take negative signs. Here this 30 sine 30 comes downward direction. That's why we take negative sign. And putting the value of sine theta in this equation, we got 30 Newton, means value of summation of V. Now putting the value of summation of H and summation of V in this formula and find the value of R. We know the magnitude of the resultant force, that is R is equal to under root of summation of H ka whole square plus summation of V ka whole square is equal to under root of, we have summation of H is equal to 16 Newton and summation of V is equal to 32 Newton. Putting these values in this formula and we got a resultant force, that is 35.8 Newton. Okay guys, now in next slides we are going to discuss about moment of force. It is another important topic of this unit. What about moment of a force? It is the turning effect produced by a force on the body on which it acts. The moment of a force is equal to the product of the force and the perpendicular distance of the point about which the moment is required and the line of action of the force. Mathematically we have a formula, that is M is equal to P into I, where P is equal to force acting on the body and I is equal to perpendicular distance between the point about which the moment is required and the line of action of the force. In that case, always remember that we need a point on a particular body. After that we are going to calculate the moment of a force. Without point we are unable to calculate the moment of a force. So before calculating the moment of a force on a particular object, so first of all we have select some point about which we are going to calculate the moment. Now we are going to discuss about units of moment. What is the unit of moment? Since the moment of a force is the product of force and distance, therefore the units of the moment will depend upon the units of force and distance. Thus, if the force is in Newton and the distance is in meter, then the units of moment will be Newton meter, as denoted as Newton meter. Similarly, if the units of moment may be kilonewton meter, that is kilonewton meter, or Newton mm. Now we are going to discuss about types of moments. So basically we have two types of moments. First one is clockwise movements and second is anti-clockwise movement. In clockwise movement, it is the moment of a force whose effects is to turn or rotate the body about the point in the same direction in which hands of a clockwise. Means the direction of the clock, if we are going to calculate moment and the direction of that moment is equal to clockwise direction, then we will take it positive moment. And what about anti-clockwise moment? It is the moment of a force whose effect is to turn or rotate the body about the point in the opposite direction in which the hands of a clock anti-clockwise. It comes under the category of anti-clockwise rotation. So we have two rotation. First one is clockwise rotation and anti-clockwise rotation. Generally, the sign convention is to take clockwise moment as positive and anti-clockwise moment as negative. Now, we are going to discuss about Varignon's principle or law of moment. It is again important topic of this unit. With the help of that principle, when we talk about coplanar forces, non-concurrent forces. In non-concurrent forces means we have multiple forces and all forces acting on different points. In that case, in numerical portion, may be asked what is the distance of a particular resultant force about some points. Point may be A, point may be B. So in that case, we are going to apply this principle. Basically, it states if a number of coplanar forces are acting simultaneously on a particle, the algebraic sum of moment of all the forces about any point is equal to the moment of their resultant force about the same point. Now, with the help of examples, we are going to discuss about principle of Varigness theorem. We have four forces equal to P, 2P, 3P and 4P are respectively acting along the four sides of a square, that is ABCD, taken in order. Find the magnitude, direction and position of the resultant force. We have a diagram. In this diagram we have A, B, C, D, and along the four side we have a force, that is P force along AB. We have 2P along BC, we have 3P force along CD, and we have 4P force, that is along DA. Now, the system of given force as shown in figure, magnitude of the resultant force. First of all, we have to resolve all the forces horizontally or vertically. Already all the forces having in horizontal direction or vertical direction. No one inclined force are available there. So don't do resolution of forces. So with the help of resolving forces, resolving all the forces horizontally, there it is summation of H. So we have two horizontal forces, that is P and 3P. P comes under right hand side, that's why we take it positive. 3P comes under left hand side, so we take it negative. So we have minus 2P. Now resolve all the forces vertically, that is summation of V is equal to, we have two vertical forces. First one is 2P and second one is 4P. In that diagram, 2P moves upward, so we take it positive, and 4P move downward, so we take it negative. We take positive 2P and negative 4P is equal to minus 2P. Now we know that magnitude of the resultant force R is equal to under root of summation of H chi square plus summation of V chi square is equal to, we now put these values in that formula. With the help of those values, we are going to calculate R is equal to, that is 2 under root of P. This is our answer, means value of resultant force, magnitude of resultant force. Now direction of resultant force, we have theta, angle which the resultant makes with the horizontal, that is tan theta is equal to summation of V upon summation of H, that is 1 or is equal to 45 degree with positive x-axis. Since summation of H as well as summation of V are negative, therefore resultant lies between 180 and 270 degree, means in third quadrant. Thus actual position of the resultant force, let x is equal to perpendicular distance between A, this is A point, and the line of action of the resultant force. Now taking moment of the resultant force about A and equating the same, first of all we are going to calculate the moment of all these forces and equate to the moment of resultant forces. When we talk about moment of resultant force, we have a force, resultant force, that is 2 root 2P into x. This is perpendicular distance. We have formula, that is force into perpendicular distance. Equate to moment of all the forces. We have forces 2P. This is 2P into A. Now we are going to calculate about moment about A point. So this is our square. In a square, all the sides are equal. It is denoted by A, small a. AB is equal to A, BC is equal to A, CD is equal to A, and AD is equal to A. For this force, 2P into perpendicular distance, this is line of action of 2P. This is perpendicular distance, that is A. Plus this is 3P. Again force 3P. This is line of action and this is perpendicular distance. Again we have AD is equal to A into A. What about force P and force 4P? What about the moment of these forces? And the moment of these forces is equal to 0, because we have a 0 distance. We have a knot. When we are going to calculate moment, we need a point, and we have point, that is A. And all the forces passing on that point about which we are going to calculate moment, the moment of all these forces is equal to 0, because there is no perpendicular distance, means distance is equal to 0. Force into perpendicular distance, we have force, but distance is equal to 0. That's why the moment of these forces is equal to 0. Now with the help of this equation, x is equal to 5a divided by 2. This is our final answer, means our resultant force passing at a distance that is 5a upon 2 root 2 from that a particular A point. The moment of the force P and 4P, this is P and this is 4P about the point A will be 0 because as it is on passing through that point. Now we are going to discuss about Lemmy's theorem. It is an again important theorem. With the help of that theorem, we are going to calculate the value of unknown forces. Now it states if three coplanar forces acting at a point be in the equilibrium condition, then each forces is proportional to the sine of the angle between the other two forces. Mathematically, we have three forces, that is P, Q and R. When we talk about P forces, it is inversely proportional to sine alpha. And what is the alpha? Alpha is the angle between these two forces. Now when we talk about Q forces, it is again inversely proportional to sine beta. Beta is the angle between force P and force R. And gamma is the angle between force P and Q. Now we are going to derive this formula with the help of Lemmy's theorem. We have a formula, we have a diagram. In this diagram we have OA, OB, BC, AC. It is a parallelogram OA, OB, CA. Consider three coplanar forces, that is P, Q and R, acting at a point that is O, capital O. Let the opposite angle to three forces be alpha, beta and gamma as shown in figure. In this diagram we have force P here, force Q here and force R here. This force is generally equal to R because it is opposite force. It is positive force, is it negative force, but magnitude will be same. So it is denoted as R. This is the angle alpha between force Q and R. This is angle beta between force P and R. This is gamma, force between P and Q, opposite to this R. Now let us complete the parallelogram, that is OACB. This is OACB. Now complete this parallelogram with OA and OB as adjacent side as shown in figure. This is OA and this is OB adjacent side, which represent force P and Q. We know that the resultant force of two forces P and Q will be given by the diagonal OC, both in magnitude and direction of the parallelogram OACB. We have already know the properties of law of parallelogram in the calculation of resultant force. In that law, we know about that in a particular parallelogram, the diagonal of that parallelogram will represent the resultant force. Since these forces are in equilibrium, therefore the resultant of the forces P and Q must be in line with OD. This is OD. This is line OD. This is OC and this is OD. And equal to R. But in opposite direction. Now from geometry of the figure, we find BC is equal to P. This is our BC. It is equal to P force. And AC is equal to Q. This is AC. It is equal to Q. Because we have a property of parallelogram. Opposite sides are equal and parallel. So this we have OB equal to force Q. That's why it is equal to AC, that is Q. Now in triangle AOC, this is triangle AOC. When we talk about triangle AOC is equal to 180 degree minus beta. This is total 180 degree and this is angle beta. If we are going to subtract beta from 180 degree, we got angle AOC. And angle ACO, that is angle ACO, is equal to angle BOC. This is alternate interior angle. This is alternate interior angle is equal to 180 degree minus alpha. Alpha is here. This is our alpha angle. This is 180 degree. When we are going to calculate this BOC means 180 minus alpha is equal to angle BOC. Now What about angle CO? We know that the property in a triangle, all the angles, the summation of all the angles, that is 180 degree minus angle AOC plus ACO. We have a value of angle AOC, put these values in this equation, and putting the value of ACO in this equation, we got a final conclusion, that is alpha plus beta is minus 180 degree is equal to angle CO. But we have alpha plus beta plus gamma is equal to 360 degree. Subtracting 180 degree from both sides of the above equation, we got alpha plus beta minus 180 degree plus gamma is equal to 360 degree minus 180 degree is equal to 180 degree. Now this is equal to CAO, angle CAO, that is alpha plus beta minus 180 degree. Put the value of alpha plus beta minus 180 degree equal to angle CAO here is equal to 180 degree minus, this is positive here, goes to opposite sides, so we take it negative. So angle COA is equal to 180 degree minus gamma. Now we know that in a particular triangle AOC, so with the help of sine formula, we have an equation, that is OA divided by sine angle ACO. Means this is angle opposite to that side, OA is equal to AC. This is AC side, and the opposite of that side angle is AOC is equal to OC, and opposite of that OC side we have an angle, that is CO. So it comes from sine formula. Now putting the value of these angles in this equation, we got OA sine. We have a value of ACO, that is 180 degree minus alpha. Putting the value in this equation, same. Putting the value of AOC here and CO here, we got a final conclusion, that is P upon sine alpha. We know that sine 180 minus alpha is equal to sine alpha, sine 180 minus beta is equal to sine beta, and sine 180 degree minus gamma is equal to sine gamma. So we have a final conclusion that P upon sine alpha is equal to Q upon sine beta is equal to R upon sine gamma. Here alpha is the angle between other two forces. When we talk about force P, means the alpha is the angle between Q and R. When we talk about Q forces, that beta, it is the angle between P and R. And we talk about R forces, the gamma, it is the angle between P and Q. So this is our final conclusion of Lami's theorem. Now we are going to calculate or numerical on Lami's theorem. We have an example, that is an electric light fixture weighing 50 Newton hangs from a point C by two strings AC and BC. The string AC is inclined 60 degree to the horizontal and BC at 45 degree to the horizontal as shown in figure. Using Lami's theorem or otherwise determine the force in the string AC. Now with the help of that numerical, we are going to calculate the value of AC in that string. So this is a diagram shown here. Now we have weight at joint C, that is 50 Newton. Let TAC is equal to force in the string AC. This is AC, and TBC is equal to force in the string BC. The system of force as shown in figure. From the geometry of the figure, we find the angle between TAC and TAC, that is 50 Newton, is angle between TAC. This is our TAC force and 50 Newton force, and the angle between these two forces, that is 150 Newton, 150 degree, and the angle between TBC, this is our TBC, and 50 Newton, and the angle between these two forces, that is 135 degree. So apply triangle ACB. This is our triangle ACB is equal to, this is our total angle 180 minus 45, we got angle ACB, that is 75 degree. So we have three angles, that is alpha, beta and gamma. Now we are going to apply Lami's theorem equation at point C. We have 15 divided by sine 75. This is our 15 Newton force, and the angle between opposite to these forces, remaining forces, that is CA and CV, that is 75 degree, is equal to TAC. This is our TAC force, And the angle between the remaining two forces, that is 135 degree, putting the value of theta 135 here, is equal to TBC sine 150 degree. 150 is the angle between force TAC and 50 Newton. Now applying these values in this equation, we got a value of TAC is equal to 15 sine 45 degree divided by sine 75 degree is equal to 10.98 Newton. Means with this 15 Newton force, we have a tensile force in that string AC, that is TAC. It is 10.98. So with the help of Lami's theorem, we are going to calculate the value of unknown forces. It may be two forces, it may be three forces. So by applying these Lami's theorem, we are going to calculate the value of unknown forces in the particular string. Thank you guys. In next lecture, we are going to cover unit 5th of mechanics. That is subject of basic civil engineering and mechanics, BT 204. Thank you everyone. Thank you so much.